So I'm going to introduce Lonnie, and Lonnie's going to do a nice presentation on EVs, EV charging, EVs, and all that. I really do think this might be our future. Not our future, but performance contracting. As I mentioned in this blurb I wrote, I don't know if anyone read it, but you know, a lot of people already done LEDs. A lot of buildings, there's a lot that haven't yet. But once the LEDs are done, how are we going to finance the new chillers and the new package units? Well, we need some ECM that's going to give us a really good payback, and then we could put in the chillers with the savings from the good ECM. And depending on where you are, this might be it, or at least that's what I'm hoping. So Lonnie is, I guess I met him years ago at World Energy Congress. It's called AE World now. He is a fantastic speaker. In fact, first time I spoke to him, I think I told him I wanted to hire him. Is that what I said? Something like that?
Yes.
And I did. And then he left, and I was really mad. But he's still a really good friend. Anyway, Lonnie, he used to work in factories. He was, I don't know if he was a plant manager, I doubt that, but I think he was in charge of energy efficiency and I don't know, maintenance or something like that. But he's worked in a lot of factories. He's really good with hands-on type stuff. And he's got a wide mind, let's say expansive mind. And he's one of the few people you'll run into who actually reads books. Nobody reads books anymore. And what that means is he's always thinking new thoughts. His mind's open, he's always learning, he's always thinking. Lonnie is amazing. Anyway, so Lonnie works for Autel. I don't know who they are, and I'm sure he'll tell us, and he's going to tell us more about EV charging. It's all up to you. Go for it, Lonnie.
Thanks, John. That's pretty good words from you there. Let's see. John and I talked a while back about the need for the industry, for the energy efficiency industry to kind of get the electric vehicles, and there had to be a way, and this presentation is part of that, to try to pull them into the fold. And I know that there's a lot of people in this audience that are not from energy efficiency, performance contracting, and this presentation should have a little bit of everything for you guys. There should be something that interests everyone, or at least it'll spike your interest and you can dig a little further. So for those people that aren't from that business, I will tell you that ECM means energy conservation measure. So I am the senior sales manager on the East Coast for Autel. Autel made their name in the automotive diagnostics. If you were to walk in any of 500,000 garages around the world, you would see something made by Autel. Scanners, tire pressure monitors, battery condition indicators, you name it, they make it. And they have a really good name in there. And they've used all that knowledge to launch into the EV charger business. All right, I hear from a lot of people, it's too fast. We're moving too fast, it's crazy. But I just want us to back up for a second and think about it. We've actually came out with our first hybrid in 1999. It's 23 years ago. We've been at this for longer than we think. I actually owned this vehicle for a while. I had a 70-mile commute at one time, and this thing would get me there on 1 gallon of gas. And it was the mileage king for many, many years. I'm not much of a slide reader, so I'll just touch the big ones on this, and you can read at your own pace. But I just wanted to say that EVs and PEVs is the same thing. It's electric vehicle. Here we got our EVSE, electric vehicle supply equipment. That's mainly what we're going to be talking about today. The rest of these, I'll give you a couple seconds and you can read through them. All right, that was fun, huh? All right, let's review the types of vehicles that are out there. Surely everybody knows the first one, the internal combustion engine, the gas diesel. Most of us are driving that or some version of it today. And then there's the hybrid, which I just showed you a picture of with the Honda Insight. And that actually uses the battery and the internal combustion engine in a combination. The braking actually recharges the battery, but there is no way to charge that battery other than operating the vehicle. And then we got the plug-in hybrid, which I've had a couple of those, the Chevy Volt being the most ubiquitous, and now Prius, and there's a bunch of them out there now. There's a ton of them out there. Let's see, that allows you to go in full electric mode. I have a plug-in hybrid Cadillac EOR now that'll go 40 miles. My son has a Honda Insight that'll go 48. And then there's the battery power. That is the full electric vehicle. No gas engine at all, nothing coming out the tailpipe because there is no tailpipe. Extremely high torque. That's mainly what we're going to be talking about. So EVs are being implemented, as you all have heard, EVs are getting very ubiquitous and they're being implemented at a very high rate. Why is that? Why all of a sudden? I mean, they've been around a little while. The vote came out in 2011, I think. So why now are things ramping up the way they are? Let's talk about a few dynamics that are causing that. Obviously, the more you use something, the cheaper it's going to get. And look at the annual lithium ion demand. It's gone up, up, up. And as it goes up, the price is going to go down. Well, how much has it gone down? It's gone down 90% in the last decade. I mean, that's crazy when you think about it. That's why the prices of electric vehicles are starting to become, or actually are, more realistic. One of the reasons. Another reason that all of a sudden they're becoming more popular. The range of these vehicles has gone up, and it keeps going up. That's the number one concern a lot of people have is, well, I just can't go very far in it. My wife has a Chevy Bolt. It'll go about 240 miles, which is a pretty good distance. Where I live, we can go to Charleston and back. It's a 2-hour trip on a charge. Another thing that's helping is incentives. Obviously, the federal government's pushing a lot. State governments are pushing. So you can get tax credits. One thing I wanted to talk about a little bit here is electrification incentives. And I want to make sure people understand when some people get upset and they think, you know, if it wasn't for subsidizing, this would never work. Electrification incentives, those of us that have been involved with utilities for a long time know that that's based on money. These electric utilities know that if you convert your transportation to electric, they've got a steady source of revenue and you're helping their baseline load big time at night. So this is no different than when they used to give you money to go to a water heater or an electric stove. It's the same kind of thing. And trust me, they are really stepping up on this because it's such a huge amount for them. So some other advantages, and I have a few slides that kind of say the same thing but in different ways, but you can look at how much oil consumption can be slashed based on switching to electric from gas, the operating cost. Same here, all electric vehicles are the lowest with 500, 850, and then you can see plug-ins, hybrids, gas, and diesel. The fuel cost is just much less for electrical. I did a couple of school bus project analysis in a previous life, and this is some information that I came up with. School buses are a gold mine of an opportunity, by the way, for this. But you can look at this and you can see that there's a very significant energy cost savings associated with just the fuel cost. I mentioned A-Fleet in this, the Alternative Fuel Life Cycle Environmental and Economic Transportation Tool. That's free, provided by the government. If you're going to do any analysis like this, especially on fleets, you need that tool. I probably spent 2 weeks playing with that tool to understand it. It's a very powerful tool, very useful to come up with numbers like this. Now, some of the projects I looked at for school buses, I could get a payback of less than 4 years. And hear this, no funny money, nothing. I think maybe a little bit, it wasn't actually a grant or anything, it was the utility agreed to pay for the transformer because they were going to make some money on the back end. But very strong projects, especially for ESCOs, they're starting to get looked at very hard. So I'm not much on text, but I got to get through this one. Some notes for ESCOs and project developers about this. Barn door applications, and that means that the vehicle leaves and comes back to the same place every day. These can be very lucrative. I just mentioned A-Fleet. Make sure you learn how to use that tool. A lot of good YouTube videos on there. School buses are just awesome. A couple reasons. Obviously, one is they're parked at night, but even better, they're parked during the day. So they make a route, they park, they make a route. So you got all kinds of time to charge or use those buses to supply the grid. So they really have a good payback. And to be honest, the bottom end of a school bus hasn't changed in 50 years. So if you're going to do a project with school buses, I personally would recommend use a retrofit kit to convert it to electric. If you buy a new school bus, you're not going to get that 4-year payback. You're talking $125,000 for a retrofit kit versus $350 for a new school bus, a new electric school bus, which Basically, some of them are just a diesel bus with an electric drivetrain, which is what you would do with the retrofit kit anyway. The last bullet here, always meet with the utility company, see what they will bring to the table. You got to hold their hand a little bit. When I had project meetings, I would insist that they would be there. And when they see how many chargers you're going to put in, what kind of load that's going to be, all of a sudden they start coming off some money. And sometimes they'll even start coming off the work. They'll put in the capital improvements that you need or help with that so you can put in the charging stations. That last highlighted sentence there in bold comes from the world that I used to be in. I worked so hard to lower the building's power usage, and now I'm going to add load with chargers. Are you kidding me? So how do we get through that? Well, you should always use smart chargers so you can deduct the usage, because smart chargers will tell you the kilowatt hours that are used. And if the charging is making money, then you need to deduct that, right? And obviously, if it's a super large system, then you probably want to, the utility company will probably do it anyway, but separately metered, and it will also make it easier to get that data. So this is just a typical home, 12,000 miles in a car. Let's say the equivalent was 30 miles per gallon, which is probably a little high for some vehicles out there, but you can still save about $75 a month going to an electric vehicle. Now this one is another reason. This is fuel price stability. See how it's all over the place except for the electricity. And that's because you don't just jack up a utility rate, you got to go through the PSC. So it's a long, involved process. So you don't see huge spikes. Now, this right here, this particular spike is where I bought that Honda Insight. You can see why. I was driving 70 miles and fuel went up to over $4 a gallon. This doesn't go to the current horror story where we're up here again. So a little analysis here. Is EV charging just a fuel switching maneuver? Is it just, are the savings strictly because electricity is cheaper? Well, let's do some quick math and see if that's the case, because a lot of people think it is. So 1 gallon of gas equals 33.7 kilowatt hours, right? So we know that an average cost of a kilowatt hour is about 13 cents. So if I convert strictly to electricity, I'm at $4.38. Doesn't look like I'm saving anything by switching, does it? So I'm not saving money by switching to electricity. I'm not saving, let's say the fuel cost is not less by switching to electricity. So what is the reason? Why is it cheaper to operate an electric vehicle than a gas vehicle? And this is the crux of the situation. It's actually the efficiency. The electric vehicle is far more efficient than a gas engine or a diesel engine. You're talking 16 to 25% for an ICE, 86 to 90% for an EV. And even the worst EVs I've seen are still over 70. That is the main name of the game. That's what's driving a lot of these things. That's what's driving the lower pollution. That's what's driving the lesser operating costs. And that's what you need to keep in mind. Not that it's a fuel switching evolution. And anyone that drives a gas car knows, you know, most of the energy, a good portion of it is going right out the 300-degree tailpipe. So miles per gallon equivalent. What does this mean? This was set up because most people cannot understand kilowatt hours. But they understand a gallon of gas. So we set this up so it was set up so people would understand based on a gallon of gas. If I had the equivalent energy of a gallon of gas in an electric car, this is how far it would go. So here's the math that you can get on that. The total miles, and then you would divide by the kilowatt hours consumed divided by how many are in 1 gallon, and you would get this equivalent miles per gallon. So we've beat up the fuel thing. What about maintenance? This was part of that bus analysis that I did, but it plays true for cars too. Maintenance is a big deal. You think you've gone from 270 moving parts to 2 moving parts. So you're not going to have oil changes, transmission fluid, filters, both air, oil, spark, glow plugs, DEF system for diesel, power steering, brake fluid. I mean, there's just so many other things. Take that one back, take back the brake fluid. But on the electric drive, basically there's almost no maintenance. These big systems, you might swap out the coolant every 150,000 miles, but you're going to swap out the coolant on an ICE engine anyway, too. So when we did it for the school bus analysis, and that's a diesel, so the maintenance is going to be a little higher, that's going to be an 80% reduction in maintenance cost. 80%. Big deal. One of the things that people are noticing, especially with loads like projects like garbage trucks, is that they're saving huge amounts of money on the brakes, huge amounts, because you can imagine a garbage truck goes through them quite a bit. And they're big brakes, thousands of dollars. So my Chevy Volt has 140,000 miles. I gave it to my son for college, still in its first set of brakes. There is a Chevy Volt out there with 450,000 miles on it, still in its first set of brakes. So if you drive these cars right, you can really stretch out the brakes. So as John tried to set me up with at the beginning, we'll get into that for a little bit. Let's look at the emissions and greenhouse gases based on the different type of vehicles. So if you look at the gas, obviously it's going to be much higher than the EV. Even the EV charge on the grid is much lower. And then the EV charge with renewables is going to be almost nothing, right? So the tailpipe, the smokestack myth. I've heard this one 100 times. I'm just going to plug it in and it's going to go to a coal power plant. I'm doing the same thing. But people that say that don't take the time to actually look at what's going on. And this chart does a pretty good job. You can see the conventional. This actually has the greenhouse gases or the CO2 from the vehicle, the manufacturing of the vehicle. And you can see that's not a whole lot different from an ICE or a battery vehicle. And then we have the fuel combustion and the actual energy to produce the fuel. And I think people forget there's a whole lot of energy used to produce oil. A lot of electricity is used to produce oil. And there's some used to produce coal too, and that's all captured. But you can see here that this is in the European Union, Germany and France, and this is the US. Now we're about 48% less green or CO2 if you run an electric vehicle on the grid than if you just use an internal combustion engine. And what this gets back to is the same thing we talked about earlier. It's the higher efficiency of the electric vehicle. If the electric vehicle was the same efficiency as this gas, it wouldn't be that much of a difference. But because it's so much more efficient, it does make a big difference. And this keeps getting better as the grid gets cleaner. So just a real quick table on the electric driving experience. Anyone in this group that has driven an electric car would probably agree with the majority of this. A matter of fact, the driving experience is so good that the Nissan Leaf, I remember years ago, I was at a little car show when this stuff was just getting started out. And I don't even particularly care for the Nissan Leaf as an EV, but they were offering $50 for you to sit in that car and drive it. And they had an 80% close rate. Crazy. The biggest thing you'll notice in electric cars, acceleration and the torque is just crazy. My wife and her Chevy Bolt, it's a little hatchback and she just loves that thing. Weather, they're not really weather related. You'll lose a little range when it's cold, but so far as performance, you're not going to see a big difference as you do in some internal combustion cars. Braking, we've talked about. Noise, totally different with electric, super quiet. Actually, on school buses, they notice the bus driver doesn't have to yell as much. One funny thing on the school buses is when they retrofitted them, all the squeaks and stuff that the noisy diesel engine was hiding would come out. So you just hear suspension squeaks and stuff instead of the big noisy engine. Range is the one hindrance. The internal combustion engine, not really an issue. And on the electric vehicle, it's limited to the battery. But that's being fixed with DC charging. Age effects, sometimes ICE engines change over time, get a little, don't run as well. More, the engine itself just starts wearing, you get more noise, smoke, and vibration. Electric motors aren't really like that. So range anxiety, one of the biggest hindrances that people purchasing an EV. The biggest way to fix that, they found, is just to buy one. As you can see, AAA survey found that 77% of the vehicle owners reported that their concerns over range decreased or went away after they purchased the vehicle. So as you can see here, the hybrid electric, or the market share of the hybrid, plug-in, and electric, obviously the electric one is picking up. Regular old hybrids are going down, and plug-in hybrids were going up, and now they're starting to go down as the electric picks up. So in the last 2 years, we've doubled the amount of electric vehicle models available to the public. I went to the New York City car show recently and I was shocked. There was a whole floor of that thing was strictly EVs and EV testing. So the amount of vehicles out there is just, if you can see, just it's almost an exponential change. And that's making a big difference on the adoption rate. This graph kind of shows the same thing in a different way. Instead of just the models, this is showing the number of EVs, and the prediction is that by the year 2030, 25% of our EV sales will be, of our car sales will be EV. In this country right now, we're at a 2.5% adoption rate. Europe is at 10%. And we're projected to pretty much make up that gap here in the next decade. So in summary of all those slides we just talked about, some of the key points of rapid EV adoption, we talked about lithium prices dropping, the number of vehicles has doubled and it's still going up. And gas is just through the roof right now. That helps push it also. The operating cost is less, incentives are increasing, technology keeps getting better and better, charging networks are getting more common, and environmental consciousness is increasing. So we're going to get onto the charging side of it now. So where can you charge your EV? 80% of the charging currently done is at home or work. Only 20% of it is done out of town. So just a real quick talk about electricity. This is a method we used to use when I was in the Navy. I was a nuke in the Navy. Where we teach mechanics what electricity is. So basically you got voltage is the water pressure, current's what flows through the pipe, power is what flows out the end, a combination of the voltage and the current. So power will be your watts or kilowatts. Power is what your charger is rated in. Energy is your power per time. So basically how much ends up in the bucket. So that's why your batteries are rated in kilowatt hours. So in North America, we use three main charging contactors. The J1772, this guy right here, is the North American standard. Tesla does not use this, but every Tesla is provided with a adapter, so you can use this. Reason being, Tesla owners wouldn't really appreciate driving by 10 1772 charging stations to find their one Tesla. So they all have this adapter, and it's fairly cheap. If you ever lose it, it's only like 60 bucks. DC, we have a few choices here. This is the most common, the combined charging system. If you look, the top is the J1772. That's why they say it's combined. And the bottom is the DC. The CHAdeMO here, it's only used on the Nissan Leaf and Mitsubishi Outlander. CHAdeMO is mainly a Japanese type connector. And then we have the Tesla connector. So this is just for electrical geeks like me. It's a visual calculator that shows your voltage, your power, and your amps. So I was looking for a bus. I was looking at a 19.2 kilowatt system. I can take my voltage and know that I'll pull 80 amps. I thought this was an opportunity to point out. I know the presentation jumps around a lot because that's unfortunately how my brain works, so you have to stay with me. This shows the 80% rule for EV charging circuits. So a 40 amp breaker would need 32 amps, would max out at 32 amps. A 60 amp breaker would max out at 48 amps. If you're going to have a continuous load more than 3 hours by the electric code, you have to oversize the breaker like this. Moving right along, let's talk about the types of charging. The level 1 charger, it comes with the vehicle. It's for 120 volts, super slow. Actually, it'd take you about 40 hours to charge the vehicle with that. Not real useful if you plan on doing any real driving. That's only 3 to 6 miles per hour charge. Level 2, 7.2 to 19.2. Faster, right? This is what you'd put in your house also. This is the one I mentioned needed a Tesla adapter if you have a Tesla. This is also single phase, but instead of 120 volts, this is going to be 208 to 240 volts. And it's going to give you 4 to 24 hours of, it's going to charge time. It's going to be 4 to 24 hours, typically far less than that. That would be a monster battery. 21 to 77 miles per charge. If you're going to charge with this, you're going to need a dedicated circuit. The charge rate on this is determined by the vehicle's onboard charger, the OBC. So basically, this is providing power to the vehicle's charger, and then the charger is going to do its job. Just to recap here, level 1 is is 120 volts, level 2 is 240 volts, and here's the plugs that are used. Common plugs for level 1 and level 2 chargers. You can see, we should be familiar with most of these. Here's your bigger ones for level 2. One thing I'll point out, little trick for you here, is if you're going to get a dryer plug of the 1450 put in your garage for your charger, tell the electrician that you're putting a dryer in, because if you tell him it's going to be an EV, I hate to say this, but it'll be often far more expensive. So tell him it's going to be a dryer and save yourself some money. Now, remember that I said that for the level 2 and the level 1, it's going to feed into this charger that's inside the car. So that charger is going to determine how fast you can charge the car. It's called the OBC, and this is called the acceptance rate of the vehicle. A very misunderstood concept here. Some people go out and buy a 12 kilowatt AC level 2 charger thinking they're going to just charge so much faster, but like in the case of the Chevy Bolt I own, it only accepts at 7.2. So I can get as big a charger as I want AC, and it's only going to go this fast. So keep that in mind. It's a common question. How fast will my vehicle charge? And it's always going to be limited by this unless you go with DC. So this is a table that shows all the different rates. As you can see, plug-in hybrids are often way down here at 3.3 or 3.6. The batteries aren't as big in those. So just some real quick dirty math. I don't want to bore anybody, just that you can almost do in your head. So the time, these are questions that you get asked when I'm sitting at conferences over and over and over. You get asked these same questions. So the time to charge, how long will it take to charge this car, right? Well, we just talked about the acceptance rate. So for the Chevy Bolt, it had a 60 kilowatt battery. I just divide the acceptance rate into that and 8.3 hours. But that's considering down and up. That's considering 0 dead battery. No one does that. So you're more likely looking around 5 to 6 hours to charge that. Pretty simple math, right? Miles per hour. So I know the battery size and I know the range of the vehicle, right? So taking the range divided by the battery size, I know that I can go 4 miles per kilowatt hour. So if I have an acceptance rate of 7.2, then I know that the 4 miles times that is going to be about 28.8 miles per hour. So that's the miles per hour when I charge the vehicle. And then I just threw this in for fun, the miles per gallon equivalent, since we know that that a gallon of gas equals 33.7 kilowatt hours. I can multiply it by my 4 miles. I should have said kilowatt hour here, but it's going to equal 134.8 miles per gallon equivalent. Just another real quick way to calculate that. So I have a pictorial here to show you what I was talking about between level 2. See, this is the onboard charger. So basically the level 1 and 2 chargers, not even really chargers, they're just very sophisticated extension cords. Now the DC fast charge, different animal altogether. It is a real charger, and it's going to take my 483 phase and it's going to convert it to DC to charge this battery. So it's going to bypass this and it's going to dump it straight in the battery, which is why it's called a fast charge, because all this limiting acceptance rate stuff is gone. So what protects the car at this point, the battery, is just the battery management system is not going to let the battery get too hot. I mean, if you try to pour it in too fast, it gets too hot, it'll shut down the charging. But you can pour in quite a bit before you get too hot, actually a shocking amount. So now that we understand that, we'll talk a little bit about level 3 chargers. And these are also called DC fast charging. These are fast. These are what you're going to see on corridor applications, which is like freeways and stuff, where if people want to take their electric vehicle on long trips, you're going to need this. You don't want to sit around in a rest area for 6 to 8 hours waiting for a level 2 charge. You want to use this that's going to snap it up to 80% in half an hour or so. Charge time is like an hour and a half to 5 hours, depending on the battery size. And I'll explain a little bit, you usually go for multiple stops at small amounts of time. And the only protection is the battery control module, or the BMS system. The connectors we talked about earlier are the CCS, the CHAdeMO, and the Tesla connectors. And one thing that these are going to offer, and some do now, and we have one coming out soon that will also, Autel does, is V2G, vehicle to grid. And that's going to allow you to take the battery and pump it back into the grid or your house. Level 4. This is a relatively new one. This was broken out like a year or two ago. This is for big stuff. We make this too. This is super fast. I mean, you see this one's so big that the power modules are in a separate cabinet. You can see back there. And the dispensers, some people just call them the gas pump, are out front. This thing really cranks it out. I believe this one will go 500 amps. When they get this big, you have to have liquid cooling in the cables, because if you pumped 500 amps through that cable without it, it would get extremely hot to the touch if it didn't fail altogether. So a little bit about charging. Just like a lead acid battery, when you charge, it's going to really go up to that. It's going to go up to that 80% very fast, right? And then after that, the charge rate's going to go down. Just like a lead acid battery, the voltage here, there's a big difference going to drive the current, so it's going to go up fast. And then as the voltage gets higher, the difference between the charger and the battery is less, and it's going to go less and less and less. So you hear this a lot. It can charge at 80% in 30 minutes, 80% in 20 minutes. That's because this is a key point right here. So I have a friend that owns a Tesla, and he drove from here. I live in South Carolina. He drove from here to Florida, so probably drove about 8 or 10 hours in his Tesla. And what he did, he would make 2 stops of about 10 to 15 minutes each, just to snap that battery back up to 80% and then keep going. It makes a lot more sense to do that than to play around with this. You're not getting much done here, but you get a whole lot done here. So that's why you hear about the 80% quite a bit. So back to some simple math, and I promise I think this is the end of the math, but let's do the same thing we did earlier. The time to charge with DC, right? We get rid of all that acceptance rate stuff. So let's say I have a 40 kilowatt DC charger, 60 kilowatt battery. Well, if I'm doing a full down and up, like 0 all the way up to 60, then it would only take 1.3 hours. But as I just explained, you're typically just going to go up to the 80%. And you can get there usually in less than an hour. Miles per hour, same kind of math. We find out that there's 4 miles per kilowatt hour. So we know that if we're charging at a 40 kilowatt hour rate, we're going to be charging at 160 miles per hour. So as we already explained, there's no acceptance rate. So this is truly why it's called fast charging. So in summary here, we talked level 1, 120 volts, slow 1.44 kilowatts per hour. Level 2 is the most common, by the way. That's the AC 208 to 240, and it's a smaller power one at home, and you can get the high power up to 20 kilowatts out in public. And then the DC fast charging, which, no surprise, it's by far the fastest, but it also can be the most expensive. And from an installation viewpoint, we'll talk a little bit more about that later. These are 208 to 240 single phase, so a lot of existing businesses will be able to put these in because they already have those circuits in place, and sometimes, you know, we over-engineer, so there is opportunity there. This one is going to require 483 phase, so you may have some significant infrastructure on this one if you don't have that in place. Another system that's out there, FreeWire makes one, is a battery-backed EV charging station. So basically you have a battery working in conjunction with a charger to charge the car and working in conjunction with the grid. So this is for demand spikes and stuff. Let's say all of a sudden the demand starts peaking, I can use this battery to do the charging instead of the grid. Or if I'm grid limited, what if I only have so much capacity there? I can use this battery and fill it up during times when there's not as much load on the system, and then use the battery when there is. Not unlike some of the demand limiting battery storage systems that some of you ESCO guys are familiar with. So I'll just spend a couple slides on this, just a real quick look at exactly how does the charging work. When you connect the charger, a whole bunch of things happen. A handshake happens, and it's looking at some things: the battery state of health, the battery capacity, the rate, the voltage amps. There's a whole lot of things that it looks at. Once the process is eliminated, the cable becomes locked, and you have to unplug it. You cannot stop the charge, but you cannot pull that connector out under load. It will automatically stop the load before you pull it out. So you can look at the cable here. This is the typical JE1772, this side. Just your power, L1, L2, proximity detection. That's what's going to kill it. Whenever you pull it out, it's going to kill the circuit before you pull it out under load. Obviously a ground, and then we have this control pilot, which does all this vehicle communication stuff. And you can see here, it does a whole lot of stuff, but we're not going to really get into the weeds on this one. I just wanted to show you that it is quite complex. Why would you want a smart charger? And that's basically all we sell, smart chargers. And first off, to tell you what a smart charger is, maybe I should tell you what a dumb charger is. A dumb charger is not connected. You plug it in, it charges your car, that's it. A smart charger gives you data connected to the internet, gives you a lot more robustness in that way. So some of the benefits are you can get real-time information on the status, availability of the charger. You can track, big one here, energy consumption. You can gather data on the patterns, improve the system. That's only going to get better. Eventually, we're going to be able to determine the make and model of the car. You can distribute energy between. You can invoice, billing, make money with the charger. That's a big one. Obviously, being shown up on a map is a good thing. And you can integrate with your route. You can allow users to reserve charging spots. Some airports are doing that now. It's super cool. So OCPP was one of the acronyms we talked about earlier, Open Charge Point Protocol. And that's basically allows hardware to talk with software. So let's say we have an Autel piece of hardware, and let's say, God forbid, they want to use ChargePoint with it. Our OCPP allows those things to happen. Or if you want a ChargePoint to use ours, it allows compatibility with different chargers and platforms. ISO 15118 allows you to see the vehicle types. It also works with vehicle to grid. Unfortunately, only 2 vehicles are signed up on that yet, but eventually I think everything will be. That's just a real quick dashboard of some of the things that you might see with the cloud. Some of you guys that are used to BMS type stuff or EMS stuff, you'll see similar, usage. You can tally up like an enterprise, multiple sites on one dashboard, tally up your patterns, your usage. Let's see. Dynamic load management, we offer that too. Basically, if you look at the chart on the left, you can see that if we were to charge at these times, we're going to make these peaks even worse. And, charging 11 vehicles at 50 kilowatts, we're going to pay this much. With dynamic load balancing, I'm going to move this stuff around. So I'm going to schedule the vehicle or actually use real-time measurement to decide, to drop it down. I'm sorry. We're going to drop down the actual usage of the vehicle so that we can mitigate this horrible cost to drop it down. It looks like $20,000 here. Now I'm going to try a video now. We'll see if it works. All right, I probably could have spent half a day trying to explain that, but I think the video did a pretty good job of explaining how it works. Same technique can be used in the house. Our charger actually has RS-485, so you can hook it up to a smart meter, And you can set, and that way you can actually mitigate the charging or lower the charging when you have a bunch of loads inside the house to try to keep you from getting a demand spike in the house. As I said, smart chargers come with an app, and you can use this for scheduling. You can stop and start, use remote access. You can actually, I have this charger in my house, and you can actually see your monthly consumption. It's really cool what you can do with it. I was kind of shocked. If you look at this, it actually, well, this one doesn't show, but you can see that the voltage in amps is within a tenth of a unit on it, which really kind of shocked me being an electrical geek. So how do you find electric chargers? Those of you that have one already know the answer to this. Typically, it's using apps. Websites do, planners, but typically you find out which apps work the best, and you can find the charger on there. So how much does it cost to put a charger in? Let's see. Level 1 is obviously going to be super cheap because it's only 120 volt circuit, so you may already have it. Level 2 is going to be a little bit more. You're going to need a dedicated circuit. Level 3 is going to be much more expensive because it is a 483 phase system. So what are some of the things that you look at when you want to put a charger in? Since this is an ECM we're talking about, right? Lighting is really good to have. Some people like to beat these things up for whatever reason, maybe steel copper. So lighting, security lighting, signage is always good so you know that it's there. Protection for the charger, because there's always somebody that tends to run into them for whatever reason. Curb stops or bollards. And cable management, which I think I talk about here. We go. Cable management is a system that prevents the cables from laying on the ground. Prefer a weighted system, which is just a counterweight inside, like an old window sash for some of you that might have an old house or seen one. Works a lot better than the spring systems. I've seen the spring systems on display not work. They just wear out and just hang there. So cable management becomes more important in colder weather because you leave the cable laying on the ground, then the snowplow comes by and whacks it. It's covered up. So how much money can I make with an EV charging station? That's a pretty common question. And this chart just shows some different scenarios. Obviously, a popular location where people use it a lot is going to get you more money the more chargers that you have. So for a popular location, we're running anywhere from $5,000 to $10,000 a month for a popular location. So real quick flow chart here about things to consider. I had about eight slides for this topic. I thought we'd break it down into just this one. Things that you want to think about if you want to put in a charging station. The actual cost of the equipment, obviously. Wall mount's always cheaper. If you go with pedestal mount, you're going to have to trench, you're going to have to run conduit more. It's just a bigger expense, and bollards and protection and all that. The location, you might use market analytics to figure out the best place to put it. There's companies that actually do that. The installation cost is always something to look at. Are you going to have to upgrade the utilities, the monthly cost of the electricity, network? How much are you going to have to pay for that? When you put in a charger and you want to make money off it, you're going to have to pay a fee to somebody. There's software that is used for that and does the billing transactions and keeps up with it. Other things like lighting, preventive and corrective maintenance. Not a big deal on AC, but on DC, I do see filters and stuff that need to be looked at, and extended warranty coverage cost. All right, getting close to the end, guys. Some models that you can use to charge. Charging by kWh, that's a real simple one. But some states don't allow you to resell kWh, so you can't use that one. And it doesn't prevent people from, what if you top your battery off? And typically, we're in an early adoption phase. The EV chargers are in premier charging spots. So people will go there and just park their EV there all day and go shop. So if you just charge by kilowatt hour, you're not going to stop that. It's called camping, where they just hang out at your charging station. Charging by time, that just gives you just charge the person by how long they're there. My personal favorite is the combo, where I charge by the consumption and the time. So I get paid for the electricity and I punish them if they decide to hang out too long. Flat rate doesn't care about the time or the electricity. It's just a big chunk of change that they hand over. And then free charging. Why would you do that? Why would you put all this money into infrastructure for free charging? Well, think about it. Right now, we're in the early adoption phase. The typical EV owner is a six-figure income, affluent, educated. These are the kind of people that you want walking through your door of your store or your retail center. So bringing those people in is not a bad idea at all. And for companies, it's a good way to get certain employees or prospective employees look at that sort of thing. So, in summary, don't get hung up on the politics and the overdose of media attention, and that's good and bad. If you guys remember the Chevy Volt, it caught on fire when it was sitting in a warehouse after it was crushed in an accident in testing, and it caught on fire and the press got a hold of it and the sales plummeted. So out of curiosity, I decided to look, well, just how many internal combustion engine gas fires are there a year? And there's over 100,000. Most of us don't realize the risk. You know, we're so used to it, but you're driving around with a 300-degree tailpipe a foot from a gas tank. So if you ever flip it or anything, it's definitely a risk. So EVs are going to become adopted because they are great technology and better for the consumer. Often, the EV evangelists, as we say, only focus on the CO2, which kind of helps scare people off, in my opinion, but it's only one of the many reasons to adopt the technology. So installing a charger can generate revenue. And so this is just a review. Attract, retain, advertise new customers, project a green image, and attract and retain employees. We want to open up to questions?
Yes, I do. But before we do, the thing I want to know is how would an ESCO make this an ECM?
Just like any other ECM, they'll look at it with a payback, and the payback.
Let's say you got a hospital.
A hospital might be a little tougher because, and it depends on if the hospital wants to charge revenue to the people going to the hospital, then they can just offset the infrastructure expense with the revenue generated from it.
But otherwise, maybe a big hospital complex like a VA hospital or something, then you would buy both electric vehicles and the charging stations together, and then you would just, that would be your ECM, is the vehicles plus the
or the ECM at the hospital could be the maintenance department vehicles. You could convert them to electrical. That's and then drop out the maintenance and all that and prove a case there. General public would be a little tougher, but you can predict the maintenance guys how much they're going to use it easier too.
So what other ESCO examples would there be? School districts, I don't know. Again, it would be just maintenance vehicles. So you'd have to replace both the vehicles plus the and then add chargers. And I guess you have school buses, which would work also. What else?
School buses is a really big one, real big one. What else for school districts? Just for the employees.
Okay, but they would have to pay. Okay, yes. So let me go through some questions. We got a lot of them. Oh my gosh, I didn't know we had so many.
Good.
Well, this was Lonnie. You did good. Okay, first off, is there a recording? It's going to be available? Yes, there will be. We published it. I don't know how much later, maybe a week or 2 or 3. It ends up online. Lonnie, I don't know if you know, but I was hoping you were going to speak over at AE World and give this talk or something like this. So it's in September. I don't know if he's going to go, but I'm guessing. You guys, if you want to go, it's in Atlanta, September. But I have a feeling Lonnie will be giving this talk. We'll see. Okay, here's one.
I'm definitely considering it.
Okay, some customers are looking to add EV charging to a building's parking as part of an ESPC. How can we get any savings from this? That's right. That's what I want to know is how do you get savings from this? And what about resiliency benefits? But let's talk about savings first. So I think that isn't the answer that let's say you're a college campus, you can charge people. And so your savings is the money, your income. So you put out all this money to install the stations and then you have income and then that's how you get your savings. Is that how it works?
Yes, and then the soft stuff of getting environmentally conscious people to be more apt to join the college. You could even go down the lead path or stuff like that. It helps with all that too, the perception. But so far as strict dollars in the college, you would have to charge money for the use, or same as the hospital, the maintenance department should shift over, and then you could recoup those savings.
Yeah, okay.
And colleges use shuttles and things like that too, so there's a few applications there.
Right. Okay, let's try the next one.
No.
Okay. What are some of the primary target market sectors you see growing at the fastest rate?
Well, Right now, to be honest, most of it seems to be on fire, but parking lots are getting big, and municipal cities are getting big on it. And there's a lot of fleet adoption because of, I showed that 4-year payback, and there's a lot of fleet adoption going on for short barn door type applications.
What specific service with the many EV business opportunities is most lucrative? I come from a commercial LED with a heavy sales background, so I like selling a lot. What channels should I pursue?
It's funny that he says that. This is kind of like where LED was 5 to 8 years ago, except it's not as crazy. It's a little bit more, not quite as Wild West like as LED was. But it's very similar, because I used to do LED projects too. So the channels will be very similar, like electric distribution.
Isn't there a lot of federal money that's coming, for charging stations? I would think there's a lot of money coming, but you got to write grant applications to get it. Does that sound
There
right?
is. It's mainly going after the DC fast charging, so people will be more quick to adopt. And there's school bus money in there too.
Yeah, and I would think that you get that through, you got to work with cities and counties and federal or government agencies, not federal, but government agencies, because they won't just give it to a company or something. Here's one. I've had 4 projects quoted for level 2 chargers in the last 6 months. The cost to install has been significantly higher, on the order of 20 to 30,000. What is real?
As an old electrician, it depends on how far it is from the panel. It depends on if I got a trench through a parking lot. I mean, there's so many ways to. Every application is unique.
Also, Chad, you may be in California and everything costs a lot more there.
Yes.
What is the typical cost for charging used for a public school? Who do you charge and how much? So I've seen this over at University of San Diego. They had all these charging stations and they charged and they made money off it. People pay to charge their electric vehicles at San Diego, University of San Diego.
That's something that you really kind of need to dial in. I mean, you put the chargers in. I mean, you can estimate it, but you put the chargers in, you charge this, you charge so much, you see how much it's used. You keep tweaking it until you get the sweet spot. There's no real answer.
If you start with a high price, let's say it's like an eBay auction, right? You start with a high price and then people see it, it's like, oh, that's too much, I ain't doing that. And they don't know that you dropped the price, right? How they gonna know you dropped the price?
I wouldn't start with a super high price. Matter of fact, it'd be tempting to do a pilot, put one in and see if people use it without charging it. See what the usage would be.
Yeah, I think you're right. You go low price and then you just keep jacking it up every month until, let's see. Yes. Okay. Someone said, great webinar. Is it okay to limit charging time for public use outside of peak times, or just charge more? Oh, that's a good question. Yeah, that's interesting. Right. It's more expensive during peak times. So let's,
right.
So can you do that? Can you have it cost more during peak times?
Yes.
Okay. Would this benefit any business with a fleet?
Very much, especially if it's a barn door fleet that leaves and comes back to the same place every day. Yeah. I mean, I looked at kits. I looked at a kit the other day. It was for an F354. It was $50,000. Took 8 hours to convert it to an electric truck. And if you're using that thing a lot, it will pay for itself fairly quick.
Yeah, that's good. When standards across EVs become more standardized, and since cars are communicating with each other, has Autel looked at installing speed governors around charging stations to protect them and to assist with parking the cars for charging? May also assist with the safety of a parking lot. This probably won't protect against ICE cars and other vandalism. Does that make sense?
No, we're not looking at that right now. I think as cars get more automated, when there's no drivers at all, I think that stuff will be done without you even knowing it.
Can you talk more about the school bus L4 chargers, types, costs, etc.?
A lot of school bus projects are going for the level 2, like a 20 kilowatt unit. They don't have to have as big an infrastructure put in, and it does a decent job. Some of them will do a bunch of those and one DC fast charger Why do you think they want one DC fast charger, John?
Shoot, I don't know.
For the guy that forgets to plug it in.
Oh, that's me.
That's why.
That's me.
Yeah.
Okay. What if you want to focus first on electrical savings before dollar savings? Is there energy savings options? Okay. So let's say you don't care about money. You're just concerned about reducing kilowatt hours. I don't know. I mean, I don't think so, right? You're increasing kilowatt hours.
Sure. You would just ignore the time of use limits and all that and just run it. You know, it's kind of funny you say that, because being in this business and you've been in it forever, you know, sometimes the question comes down, do you want to save energy or do you want to save money? And sometimes the two don't match.
Mm-hmm.
So I think that's kind of what he's getting at.
Where do you get the visual voltage calculator? Where'd you see that? Oh, that was at Engineering Toolbox, right?
That was just a Google image.
The visual voltage calculator.
Oh, yeah, that was Toolbox. Yeah, that's right.
Engineering Toolbox. And they called it the visual voltage calculator. Is that what they called it?
I may have called it that. I have to look at the slide and see.
Sorry about that. Okay. This is the most questions we've ever had. Although, you know, one or two of you has asked about 6 of them. That's that one. Okay. So, yeah, I don't know. I think it's about money. If it works for money, you know, I mean, that's how we ESCOs look at things, is does it pay for itself? If it pays for itself, you do it. If it doesn't pay for itself, don't do it. And that's generally how we you know, recognize this is a good project or this is not a good project. You could totally be, you know, not buy into any of the global warming stuff and still think this is a good project if it saves money. So
yeah, you can get away from the global warming and just we can agree on one thing, that fossil fuels pollute. We can all agree on that. Maybe you don't care about the CO2, maybe you don't believe that, but they all pollute.
Yeah. Well, I mean, you can.
Yeah.
There's arguments. I don't want to go there, but I don't think that's a good argument. But I think that, a better argument is, it will save money in some places, maybe not in others. It depends. Like if electricity costs are high and gas is low, then maybe not so much. But that's not true anymore. Any place we can go to search for grants? Yeah, I can answer that. Grants.gov. I go there all the time. Grants.gov. That's federal grants. State websites, states have their own grants websites too. So you could just type in state of whatever grants, and you'll find a ton of grants, and you'll be amazed how much money they give out. What I found, okay, here's another question. What I found out is the electrical infrastructure is not installed to deliver the required output needed for output power needed for new chargers, plus the peak demand on the building storage. Yeah, right. So the electrical infrastructure isn't, yeah, therethere's not enough. Yeah. Oh, that means it's maybe not enough to the building. Is that maybe what he's?
I can see it.
That
I know, as we talked about before this, one thing about electric cars is once you start getting vehicle to grid, you'll be able to tap into that when the grid needs help, which is a big deal if you have a bunch of cars plugged in.
Yeah, we didn't get it. Right. Yeah.
That's where you eventually will go. And the other thing is that the cars are mostly going to be charging at night when the utilities have a low base load. So they love sending electricity at night because they're not up in their sweet spot. So that's one of the reasons a school bus is so popular with them too.
Oh yeah, in California they want to charge during the day, the middle of the day, and the buses aren't being used then either. So have the automakers endorsed the use of DC chargers on their batteries?
Well, they're putting in the connectors to let you do it. So I'm going to assume implied yes.
Okay, concerns local utility rates. For any ESCO responsible for guaranteeing savings, be very careful with the speaker's rate assumptions. Oh yeah, of course. Right. So he said like 13 cents a kilowatt hour. In California, it's probably like 25.
It is 25 in California. That was the national average, and I stated that.
Yeah, I mean, you go out to Washington or Idaho, it might be 4 or 5 cents. So yeah, he's right. Or whoever asked that, yeah, he's right. What's the biggest advantage over charge point?
For us,
Yeah.
But for Autel, well, we're a whole lot less expensive, and we're, from what I've been told, we're easier to deal with.
Okay.
They're the big player, but they also are getting a little bit behind on their orders and not as easy to deal with.
This is crazy, all these questions. We've never had
Really?
webinar. We got a lot of questions. What was that online tool called for school bus calcs? Dayfleet? Is that what it was called?
Afleet, AFLEET.
Yeah, A-Fleet.
It's not just school buses, it's any fuel. Like you could do compressed natural gas, propane, whatever you want. It'll do that for you for transportation.
So this might be, you might ask this, but I'm going to say it again anyway. So what are the biggest advances over ChargePoint, the leader in the industry?
Our cost, we offer more for the money.
Okay, and you're easier to work with, you said. Can all cars be plugged into a DC fast charger?
No, some, like the plug-in hybrids, typically do not have the receptacle, the CCS I talked about, the combined charging system.
Okay.
They have smaller batteries, so they don't see the need. And even now, I think most EVs come with it, but probably 5 years ago, you almost had to ask for it. It was an option.
All right.
If you're going to buy an EV, you definitely want that on there. Definitely.
Okay, Tyler, can you move us to the next slide? There are a lot of questions. I have a feeling some of you guys want to discuss this more with Lonnie. So if you do, you can contact him. I hope you don't mind, Lonnie. Email us there. We'll pass it on to Lonnie and put you in touch with him. Okay, everybody. Thanks for coming. We'll see you next month.